Assalamualaikum and hi everyone. In this video we are going to discuss about the natural source of alkanes. There are two natural sources of alkanes, which are natural gas and petroleum. 70 to 90% of natural gases consist of the methane gas, which is the simplest alkane. Ethane, propane and butane also present in the natural gases, but in a much smaller percentage. While in the petroleum, the hydrocarbons present in petroleum can contain up to 40 carbon atoms. Usually, they are separated from the crude oil by fractional distillation and cracking process. A bit about fractional distillation and cracking process. So, as you can see in the table, we can see that fractional distillation is the process used to separate components in crude oil. It used the difference in boiling points of components in a mixture, which does not include the use of catalyst. Therefore, it depends on the boiling points of hydrocarbon in the crude oil. As you can see in the picture here, the crude oil is fed into a distillation chamber and the crude oil is heated at a different temperature. While in the cracking process, it involves the breakdown of large hydrocarbon molecules into smaller hydrocarbon. The production of small hydrocarbon usually improves the octane rating. It can be done in the presence of catalyst. It does not depend on the boiling points of hydrocarbon. As you can see here, long chain alkane is broken down into a smaller alkanes and alkenes. Next, we are going to learn about the physical properties of alkanes, where in this video we are going to discuss about the boiling point and the solubility. For the boiling point, we are going to discuss the differences between alkanes of different molecular mass and isomeric alkanes, while in terms of solubility, we are going to discuss about the solubility of alkanes in water and solubility of alkanes in nonpolar solvent. Firstly, we are going to discuss about the boiling point of alkanes based on the molecular mass. As you can see here in the table, increasing molecular mass will increase the boiling point. This is due to the bigger surface area in contact as the molecular mass becomes greater. When the surface area in contact becomes bigger, the van der Waals forces become stronger. It resulted to a higher boiling point. Now, when we are talking about the boiling point for isomeric alkanes, we are going to use this example. All three compounds here have the same molecular formula, which is C6H14. Therefore, same molecular formula, meaning that they have the same molecular mass. Therefore, we need to take a look further on how the carbon connections affect the van der Waals forces. By increasing the number of branches, here we can see that this has no branch, this has one branch, and this has two branches. Making the molecules more compact, thus reducing the surface area in contact and making the van der Waals forces becomes weaker while lowering the boiling point. So, if you want to rearrange the compound, we can say that this compound has the lowest boiling point. while the straight chain has the highest boiling point. Since alkenes and cycloalkenes are nonpolar, they are soluble in nonpolar solvents such as benzene, tetrachloromethane, carbon atom with 4 chlorine atoms around it, chloroform, carbon, 1 hydrogen and 3 chlorine atoms, dichloromethane, carbon, 2 hydrogens and 2 chlorines, and other hydrocarbons such as the alkanes and cycloalkanes itself. Next, we are going to discuss about the solubility of alkanes in water. Alkanes are almost totally insoluble in water because alkanes and cycloalkanes are non-polar molecules. Therefore, they are unable to form hydrogen bonds with water. Water is a polar solvent. Non-polar molecules does not dissolve or soluble in polar solvents such as water.